Hello, Core 1 peeps. This is a quick introduction to your assignment today. I do not want to make it too long since you have some work to do, but this assignment today requires you to recall a couple of things from last week. So this week we've spent Monday, block day, and today learning and practicing how to solve a quadratic using the quadratic formula. Now, we're moving on to a different method, but the same goal. Our goal is to solve a quadratic, but the methods are changing because the form is changing of our quadratics. We're going to be using incomplete quadratics. We're going to be solving incomplete quadratics today, which actually are easier to solve because we don't need a ginormous formula in order to do so. So first, remembering this is a video that Mrs. Hernandez showed to her class. It's a minute and 44 seconds long, and it explains what it means to solve a quadratic. And what it means is we're trying to find the x-intercepts, where our quadratic function crosses the x-axis, hence the name x-intercepts. Now, we call those solutions, roots, zeros, and x-intercepts, of course. Now, how many solutions can we have? We've got our three scenarios. We've got two solutions where it crosses at 2 points. We've got one solution where it just grazes and intersects with the x-axis at exactly 1 point. And we've got no solutions where it doesn't cross the x-axis at all. Based on what the actual function is what will determine how many solutions we will actually get. So based on that, here is the first part. The first part is factoring incompletes. So to factor means I'm going to take ax squared plus bx and I'm going to factor out an x and I'm going to factor out some common number between the coefficients a and b. So first, the step-by-step, make sure you're in standard form first. Standard incomplete form, right? Because this isn't a full quadratic. It's missing the c term. So it's going to be set equal to 0. Is in standard form for this case. Step 2, factor out the greatest common factors. One of the factors is always going to be the variable x, and the other factor is going to be some number that is common to both of the coefficients in this function. The first example, we start off easy with x squared plus x equals 0. There's an x common in both of these, so if I factor one x out, I put that out front, and in parentheses is what I include afterwards. Think of this as we're doing the opposite of distributing, right? If I look at x times x plus 1, if I were to distribute that, I would do x times x, which gives me x squared, and then I would do x times 1, which gives me a single x. We're undoing the distribution there. So factoring is the opposite of distributing. And in this case, if I'm factoring out an x, well, x squared divided by x leaves me with x, and x divided by x leaves me with 1. From here, you have to think of this quadratic as, okay, this is x, and it's being multiplied by x plus 1. So if I can find some value to plug in for x here that makes, for 0 here, 0 times anything is going to equal 0. And the same thing applies. If I can find some value of x that I plug in for x plus 1, such that it makes what's in the parentheses become 0, well, 0 times doesn't matter what x is. Anything times 0 always equals 0. So essentially what we're doing is we're taking x and we're setting it equal to 0 and solving for x. Well, if you set x equal to 0 and solve for it, you've just got x equals 0. However, when you get to x plus 1 equals 0, right? Set this little expression equal to 0. And if I'm trying to isolate the x, I should subtract 1 from both sides, and I'm left with x equals negative 1. If I were to graph this on Desmos, you would see that it's going to cross our x-axis at negative 1 and at 0, exactly like what we just solved. So we found our x-intercepts. That is what we wanted. Now, that was my bad. I need to edit that. I made a goof. This should be the point negative 1 comma 0. So let's make a box, and it's going to have a white background. And let's make that tiny to cover up, cover up my mistake, and we'll put the correction there. Here we go. Now, excuse me for being a little bit lagged behind. Here we go. So -1, 0. Next example, a little bit more complicated. We've got 9x squared plus 3x equals 0. We can factor out an x, and we can factor out a 3. 3 is the greatest common factor between 9 and 3. So if I factor out a 3x, that leaves me with, well, 9 divided by 3 is 3, and x squared divided by x is x, so 3x. And then 3x divided by 3x gives me 1. So I am left with 3x times 3x plus 1 equals 0. Set each of these equal to 0, so 3x equals 0. Divide both sides by 3. Well, 0 divided by 3 gives me 0. So x equals 0. Set 3x plus 1, right? That's what's in the parentheses. Set that equal to 0. And subtract 1, right? Order of operations, we do the adding and subtracting first when we're solving. And then divide both sides by 3, so we get -1/3. So when we look at our graph, it crosses at 0 and at -1/3. And so I'm going to need to copy and paste this guy. Wherever that gets pasted. Anybody see it? Oh, there it is. Oops. That was my bad. I apologize for the technology issues here. Should have caught that before I made my video. Anyways, so then the point is -1/3, comma 0. And we will make that a little bit bigger. There we go. So -1, 0. All right, example 3. -2x squared minus 20x equals 0. What's common in these terms? What's common in -2x squared and -20x? Well, an x is common and a -2 is the greatest common number. So -2x is factored out. You've got dividing -2x squared by 2x. Well, -2 divided by -2 gives me just a single 1, and then x squared divided by x just gives me x, so 1x. And then we've got -20x divided by a -2x, and that is -20 divided by -2 gives me 10. X divided by x is just 1. Set each of these equal to 0 and solve for x, and we end up with a solution of x equals 0 and x equals -10. You graph that and you get 0 and -10 as our solutions to our quadratic. If I were to cover up this, because I made a goof, and then, what was that again? So -10, comma 0. There we go. All right, there's our solution. And last but not least, there's only one solution here. Where there's no factoring involved, you just divide both sides by a -3 and then take the square root of both sides. Anywho, moving on. Part 2 is by far, I'd say, the most straightforward way to solve a quadratic, because you don't need a formula, you don't need to do any special factoring or any methods like that. You just get to solve for x just like you normally would if you're just trying to isolate the x. So it's in the form of ax squared plus c is equal to d, so some number. And rather than putting it into standard form, we should move the c over to the d. So combine any like terms if possible first. So ax squared, if there were another x squared anywhere else in here, we would want to combine like terms first, but in this case, we've just got 2x squared minus 6 equals 2. So first, if we're trying to get x by itself, we should push everything to the right side of the equal sign. So I'm going to add 6 to both sides. So 2 plus 6 gives me 8, and I'm left with 2x squared on the left side. 2x squared equals 8. Divide both sides by 2, and that leaves me with, well, divide both sides by 2. They cancel out right there, and then 8 divided by 2 gives me 4. So I'm left with x squared equals 4. How do I undo something that's being squared? Well, I take the square root of both sides. So I take the square root of both sides, and I'm left with x equals the square root of 4. Now, the reason that, I think you guys can see this, the reason that you get x equals -2 and x equals +2 is because if I take 2 and I square it, I get 4. But if I have -2 and I square it, I get 4 as well. So I could square 2 and get to 4, but I could also square -2 and get to 4. So that's why I'm going to have two possible solutions here of 2 and -2. Whenever you take the square root of a number, you're always going to need to have a positive and a negative answer. That's why in the quadratic formula they have the plus and the minus. So +2 and -2 as our solutions. I will edit these briefly before moving on. So we should have -2, 0. And I should have just 2, 0. Feel free to skip through these parts where I'm finagling and making corrections, but I just want you to see that these are the correct answers in this case. All right, then finally number 2, x squared plus 2 equals 0. If I subtract 2 to both sides, I'm left with x squared equals -2. If I take the square root of both sides, right, because I'm trying to undo the square root of a negative, that's not possible. You can't take the square root of a negative number yet. Wait until core 3. Hopefully you guys will have me for core 3. You will learn how to take square roots of negative numbers, but right now we're treating it as if it's impossible. So there's no solutions, and you'll see that on the graph. It's because it doesn't even cross the x-axis down here below. So, did I skip? I did not skip. So anyways, this is where you guys are going to embark on this journey, trying it yourself. There are 10 questions. These will go faster than the quadratic formula. So this is your last assignment before break, or sorry, before your weekend. We don't have a break. This is your last assignment before the weekend. Get it done, submit it via Moodle, and enjoy your weekend. Thank you guys.